on normalise. C'est XP de ah oui, non, il faut que je normalise par ça. Non, c'est double. C'est un nombre négatif. Non, c'est un nombre. Ouais, mais c'est un nombre qui est plus 1. La valeur de la table doit diminuer. pas être croissant, c'est pas possible. Ah putain. Là, ça fonctionne beaucoup mieux. Okay. Good evening, everybody. I forgot something. Yes. Yeah, the cap that goes with the right color. Yeah, maybe we're gonna put some music on. Let's see what I have. Yes. release. Yes, with a bit of music, it's going to be a bit nicer. Okay. Good evening, everybody. I hope you had a nice couple of days. Yeah, I'm going to do a second session today. I hope you're going to like it too. We're going to continue on what we've been doing so far and trying to go further than that. If you remember, we were at that point. Let me show you where we're at now. I can load the right sketch. And switch my panel. Now I'm using my phone actually to record my LEDs, so I hope it's going to be better. So normally that's where we were last time we were together. We are able to display pictures using the SPI. I want to go back to some explanation about how I do it, because I received some comments about the 1 and the zeros, and I remember that actually by rewatching the live, I've seen that I've been hiding part of my screen. So what I'm going to do now is just going to hello Special CD from Ukraine. Hope you're doing well despite everything that's going on with you. I'm just gonna re-explain the 1 and the 0, and then we can start from there. So I'm just gonna switch my window here and goes back to numbers. Up. Yes, perfect. Okay. For instance, if I want to send a 1, a 0, a 1, hopla, a 1 and a 1 and a 1. Okay, let me increase the size of the text in here. So this way you can see. Just going to remove that. Yes, it's going to be better. Okay, I'm just going to extend a little bit so we can see a bit further on that. Up. 1, 2, 3, 4. Gonna merge this cell here. You will see later why I'm doing that. Merge cell. Okay. So I'm gonna send a 0 here, 2. Up. Copy format. 22. So everybody can see what I'm doing. And I'm going to center everything in here. Okay. So let's say I want to send these byte ones 0, 1, 1, 1, 0. So to create the signal, I need to do, because the basic signal is actually 1, 1, 0, 0, which creates the group. So here, if I want to on, I need to add to put a 1 here. Here 1, 0, 0. Here 1, 1, 0. 1, 1, 0. 1 and a 0, and here 1, 0 and a 0. I'm just going to duplicate that here too. Okay, so that's why I've created all this intermediary to be able to actually transform the 1 and 0s of the byte that I want to send into 1, 1, 0, 1, 1, 0, 0, 0, 1. And that's what is going to be sent through the SPI to the LEDs, and that's how I can do this kind of crazy stuff that I'm doing right now. So this was kind of the first part of it. So just as a reminder, what we've done, if you look at, no, that's not the one I want to see. Let's switch back to, Arduino SPI example. Okay, let's switch back to my example here. So what we've done, we actually created the pixel object that we need to be able to put inside the LED. We created a map function that allowed us to actually map directly an array instead of doing some mathematical afterwards. That was the first function that I used to change here my 1 then 0 into a signal that is going to be sent. And here I've done using the palette and also using a transformation of a map function. So that's what we've done right now. Okay, but we've got a little issue with actually size here, because let's go back to Excel. You will understand quite easily what happens when I do that. Numbers. Where is it again? Can I close it? No, it's there. Just a minute. I found it. Here it is. So numbers. So what do I have when I create, in terms of sizing, what are we talking about? So to create one array of LED to store my data, I need 3 bytes per number of LEDs. So let's say that I have here my number of LEDs are here. So let's say that I've got like 256 LEDs. So here everybody can see what's going on. So now, the size of the array to store the LEDs is actually 3 times that array, because I need 3 bytes, 1 for each color. But now, to send, now we've created like a huge array of data to be sent automatically. And the size of that is actually the size of bytes, the size of number of bytes that I have. And for each byte, I need to send 3 bytes of data. So I multiply that again by 3. Oh no, size of the, let's put that size of the buffer to send. It's equal to that multiplied by 3, because I need 3 bytes to send 1 byte of data. So if I had for 250, so 206, if I do the sum of these two, I've got 3 kilobytes here to send 256 LEDs, which is way more than most of the small, I would say, controller I have. And also, let's say, for instance, on my array here, I've got like 60,000 LEDs. I'll let you imagine how much that will make. So you divide that by, it's actually almost a megabyte, which is this is impossible to store that large amount of data. So how do we do with that? So what we're going to do, we're going to see how we do not create the entire stream to be sent at once, but we're going to create a small buffer that's going to be sent one after the other to be able to actually not use a large array of data, which is here, but only a couple of smaller array of data that's going to be sent times to times. Okay? By the way, I will create a GitHub when you're going to find everything stored, all my programs stored. Okay, so let's do it. So go back to my SPI example, which is here. Now you can see it. So what we're going to do, we're going to duplicate that, save as, and I'm going to call it SPI example, and let's say with buffer. Here it is. That's the one. Yeah. How do we know? That's the right one. If I tap here. Yes. Okay. So what we need to do now is actually to tell, instead of telling here, what do I do when I display my array? I transpose my entire LED data inside this, and I say you transmit all of that, but that array is going to be bigger and bigger, because if I look for it, no, not that. I'm just going to look for that. If I look at the definition of my trans data, that's 9 times the number of LED that I have, which is way, 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 way too much. Okay, so I would love something to be more like an array, because you see I will be needing 2 of them. Buffer. I know that I need 3 for LED, so I was going to say 2 times 3 times 3. So store data size, buffer to store information for 2 LEDs. Okay, why do I do that? My idea is actually I'm going to transpose one LED, send the LED, and while I'm sending the LED, I'm going to calculate and compute the second LED. And then I'm going to send them. I'm going to send the second LED, and when I send the second LED, I'm going to calculate the third one, etc., etc., etc. So with only a buffer of 2, by exchanging them back and forth, I can normally send every byte. Okay. So how do I do that? Here inside my where is my setup definition? Here it is. Here inside my setup definition of my config for my SPI, I can add a small function with actually a small interface. I can say, by the way, you need to use once you've done transferring the information, you can use a specific function. So what I'm going to do is, okay, I'm going to create a specific function that I'm going to put, because I'm using an SP32, I'm going to put it in IRAM, but that's just, I will not comment on that further. If you want, I will comment on that afterwards. See? So what I'm going to do is actually, I'm going to tell which ones send one buffer and calculate the second one. Okay, and because it's an interrupt to SPI, it needs to take this as parameters. Okay, that you need to read the I would say the documentation to know about that. That's big enough. Yes, I think so. Maybe I can increase the size a little bit of the settings. I'm gonna push a little bit size of the. Okay, so maybe it's gonna be right. I'm gonna get rid of that so everybody can see. So what I'm gonna do here, I'm gonna say, okay, now when I arrive here, I will say, okay, you need to count where am I inside my LEDs. Okay, first I'm going to say, okay, transpose using my function one LED and send the other one. Okay, so I'm going to click it like here. So transpose buffer. I'm going to see afterwards what I'm going to put. Buffer and send the buffer. Okay, now put it in the queue. That's what more or less I'm going to do. Okay, but we have already a function to transpose the buffer, and it's here. For instance, transpose data with mapping and palette, everything that we are using here. Except up here, we're using the LED, the stream where we're going to put the data, but we do it for all the LED. But we don't really need to put for all the LED, we only need to put for one LED. So I'm going to duplicate that function, saying like this. Just going to create that function. Which one am I using below? Data with mapping. So I'm going to take the data with mapping function to transpose without the palette. And I'm going to say with buffing one LED because I'm not going to change every LED, so I'm going to get rid of that because I'm just going to transpose one LED, but I need to know which LED I'm going to transpose. So I will need to have LED to transpose. Okay, and now okay, that's good. So now I have my function to transpose one specific LED into the stream. Okay, but in which stream, in which buffer can we transpose the LED? We need to know. So as we're going to alternate from buffer 1 to buffer 2, I need to have two transactions that I'm going to send. So here, if we remember, we send transactions to the SPI. I'm going to add this one here. So instead of having one transaction, I'm going to create an array of transactions. So SPI transactions, and I'm going to call them transaction trans buffers. Yes, and I need two of them because I'm going to use one transaction and then after the other one. Okay, here for each transaction I need a buffer. Okay, so what I'm going to do, I have several ways of doing it, but in there I use an array of array which has a double pointer, or I'm just going to do this. I'm just going to do two buffers. Buffer 1, which is the size of 9 because it's 3.3, and a second buffer, which is the second one. Okay. Here you remember in my setup function, here what I did is actually I can associate the buffer to a transaction. So what I'm going to do, I'm going to say transaction buffer 0 because it's always by 0, but the X buffer equal to buffer 1. And I'm duplicating that one. One is buffer 2. Okay. The transaction length is not, because here we're sending only one LED per buffer. Is equal 8 times 3 times 3 because we're sending 3 bytes for each byte of the color, so 3 by 3, and we have 8 bits per byte. Okay, I'm just going to duplicate that here. It's just a setup, and then afterwards we're gonna be okay. So I'm gonna put that here because transmit data, prepare trans data. Okay. Now you remember that what I did is actually that I had to prepare the data because I needed to add, if you look at understand, not speak English. Okay. Yeah, I'm recording the stream. Don't worry. The stream will be still available. For the moment, I'm writing one LED at a time. But soon I will show you how to write like 16 or 15 LEDs at a time, even 48 LEDs at one time. And you will see why the interrupts will not mess exactly with my definition. I will explain that a little bit later on. I'll finish that and I come back to the interrupts afterwards. Okay? So if I go back to numbers, here you see that I always need to put the first one and the last zero, the first one and the last zero. That's why we had a function when we started earlier, which I called prepare data. Okay, I don't need that here. But that my prepare data is my function prepare data is here. But here I do it for every LED that I have here. So what I'm going to do, I'm going to duplicate that function, but saying, okay, prepare data for one LED. Okay, and here I'm just going to say that's only one LED, so it's times 3. Easy. So now I'm just going to have to call this function here for buffer 1 and buffer 2. Okay. So now what's going to happen? When I'm just going to remove that because otherwise I'm going to have a huge issue. So I've got my two buffers, my two transactions. And I'm going to tell him, once you've done with transferring one buffer, you need to execute my function. So, and it's, let me find, because I always forget how is it called. CB. Okay, here I'm also going to tell him that you're going to have 2 buffers at most in the queue. You can have more, but more. And here I'm going to say this is the function that you're going to use. From now, we're not too bad. Let's put it here. Okay. So now, each time it's going to finish to send a buffer, it's going to call that function. I need to add a, because here, if I don't add a large O, it looks like I'm reading condom. And it's not what I want. Okay. But now we need to know which LED we are going to display. Because here we don't know which LED we need to refer to. So we need to start from something. So I'm going to add one global variable for the moment. So it's going to be an int. And I'm going to be LED to display. Okay. And now I'm finally going to create a function that I will call show, because otherwise it's going to be too much, too messy. So I've prepared my data, etc. So I'm going to create a function that I will call show. Void show. Allez, let's show pixel like I do usually. For the moment, I don't do anything else than that. So first things first, I say, okay, because I will display the first one while I will push the first one while I'm calculating the second one. So I need to pre-calculate some of them. Okay, so to pre-calculate some of them, I need to call my new function that I have transpose buffer, what is called transpose data with mapping one LED. Okay. Okay, so I'm going to calculate. Ooh, shoot. I forgot my copy transpose data with mapping one LED. Okay, and I'm going to ask, okay, calculate the first one. But now I need to know on where do I need to get the LEDs. So the LEDs are coming from here. That's not that complicated, I would say. And I need to know which transaction I'm going to display. If you look at my so the first stream that I need to display, that's going to be the transaction 0, the first transaction, and the text buffer of my first transaction. Sounds logical. Okay. I guess I'm missing something here. Let's see, I guess. Yeah, because I've got a map function of let to transpose, so no, it's going to be okay. So that's going to be good. Now, what I'm going to do, I'm going to also calculate the second one. So I'm going to pre-calculate the second LED. Okay. And I'm going to do that. The next LED I'm going to have to calculate is going to be the second one. So I'm going to put so LED to display equal to. Okay. But where is this number 2 LED's going to be put? It's going to have to be put in trans buffer zero, right? Because I'm going to launch the first one. It's going to be okay. Actually, I can calculate only the first one. It should be okay too. Okay. And then I'm going to calculate this one. So I'm going to tell him, okay, now you need to calculate the buffer 2, but the buffer 2 is going to have to be in here while it's displaying this one. Okay. So what I will do, yes, it's going to be okay. Yeah. Do I need to calculate really the second one? Or I will see later. Each time I do the same topic. But now I need to know, I need to track of which buffer I need to change. So I need a new global variable. Means I'm going to call it buffer number. And I put it equal to 0. Okay. So I'm going to say, and when I set my function, I say buffer number equal to 0. Okay. So what will happen? So now I'm going to send the first buffer to be transmitted. As I did, instead of sending, I'm going to send the first buffer. So once the first buffer will be submitted, will be finalized, it's going to arrive here with the validate to display equal 2 and buffer number equals 0. So what I need to do is actually, now I'm going to do here, I'm going to say, okay, now you calculate on the LED to display. On buffer, which buffer do I need to put it? The buffer number. And what do I need to do? I need to push it on the LED. So I just need to push this But how long can I do that? Because if I do that, it's going to be a loop, an infinite loop. I need to know where to stop. I need to stop while LED display is lower than the number of LED. So if when I arrive here, LED to display is below or equal num LED, then I can do that. Otherwise, I will see later on what I do. Okay? So now if I'm making not too much mistakes in my loop, I don't need that anymore. And I'm going to just call show pixel if I didn't make any mistake. Let's see what happens. I'm just going to display back the LEDs. Oh, I'm going to just turn that off. So now I have nothing. Oh. No, I'm just going to wait a little bit before sunny. Okay, I made a compilation error. What did I do wrong? It's a pointer, yes, true. It's a pointer if, so I can't put 1, I need to put error. Where did I put that again? 2 here. Text buffer is correct. It's correct. So now if I restart. Oh, yeah, because I haven't restarted then. Okay, let's recompile. No, I don't need to send. I need just to send the buffer. Here, I don't need to send that. LED to display was not declared 300. You define LED to display. Of course. What did I do wrong again? Text buffer. Let's see. Buffer number was not displayed in the course. Yeah, of course, if you define your global variable at the end, of course you're going to have an issue. Up. Let's compile. What is going on here? I don't know why it doesn't want to. Okay, that I understand. The buffer is a LED, so why there's an issue in that? Let's see what I've done the other time. the transaction. First, why can't you take the stream? What did I define as transaction? Oh, yes, I took a double. Streams, of course, it's not going to work because it's actually an array of array, which was not exactly what I wanted to do. And in that should be correct then. And that's not anymore, because that's not a pointer anymore. That's the object by itself. It's because I put an array pointer yes, yeah, it's not that. That. Then I guess on top is going to be the same issue when I go 299. Yes. Yes, I guess there is a mistake which is going to happen, but we will see. Oh, gosh, what's going on again? Why does he want to take the buffer? I'm going to just move that into a stream, to int, but I'm going to force the conversion, but that's strange actually. Let's see if I do that. Should not be necessary, but apparently it doesn't want to do it otherwise. Okay, done. So I had to force the translation from voids, pointer to void of to pointer to a star, pointer to unsigned chart. Okay, now it's going to upload. So if I put again, so let's see what will appear. Okay, everything is white. So something strange because that's not the right. To where am I sending that? Yes, the right one. Let's see my buffer. Let's see my serial monitor. Okay, I have an issue. So here it doesn't work. I'm doing something wrong. Definitely. So I've corrupted some area. So I'm not writing at the right place. I should not. I guess I'm not writing at the right place. It's because I cannot send more than that. First. Okay, let me check what I've done wrong too. The size is correct. It's correct. Data for one LED. Three times 3. That's. Oh. No, that's correct. let's see my buffer 1. Nine, buffer 2, 9. That's correct too. Okay, let's remove the show pixel. Let's see if it's while I create the okay, so it seems that it's when I launch, when I create the here. So what did I do wrong? So when I transpose the data for mapping with one LED, I do something wrong. So I send it to the buffer. Seems correct. Let's see what am I doing wrong here. Oh no, I know what I'm doing. I'm always trying to write at the same time because I'm always writing in the same buffer. First, I need to say that once I am here, I need to increase the LED I'm displaying. And then I need to say that I need to increase the buffer too. Equal buffer number plus 1. Modulo 2, because I have only 2 buffers. If I don't do that, I will not do a lot of stuff. Okay, now I've got something, but apparently okay. Apparently I'm not sending anything. So I did something wrong somewhere. I changed the buffer. I map the second one, which I transfer to the buffer, and I push the buffer. I increase the number of LED. I increase the buffer. So what I'm going to do first in my loop is to display if I've... Oh, I don't call the show pixel the phone. I don't call the show pixel, it's not going to happen. Okay, we're almost there. We still have issues, but we're getting there. We're having something which is displayed not at the correct place, apparently, but we're getting there. So let's see if I can manage the error. Still some memory which is corrupted. iCore was running on the ISR concept. Okay, so I was running inside an ESR and I did something wrong. first I can certainly do that. And I think that's because of this. Let's do that. I will explain if it's because of the delay. Yes. So now it's displayed correctly, but I still have the errors. You will still see something. Now the error within the will disappear. So now you see you don't have any more errors here. It doesn't bring any error and everything is clean on top of it. So now it's not the same color because I've put a small black piece of glass on top of it. So let's see, if you look at this line, which is here, if I put 20 here, wait 20 milliseconds, what will happen? If I'm not mistaken, we will have an issue. And here it goes. First, on the top here, you see that I have part of the screen which is display, and I've got a reboot here with corrupted image. So why, by changing the delay time, do I avoid this? It's simply because when I run showPixel here, all this code becomes purely independent of the rest of the code. So it's sending that, and then my interrupt functions runs, but without having any conjunction with the main code. So the main code doesn't really know when the showPixel is finishing. That's the issue. So we need to tell the showPixel, by the way, I'm finished. And the way to do that is actually to call a semaphore. So I'm just going to arrange. So a semaphore is a type of object that you can do that several ways. I like to use semaphore because it's fun and funny for me. So I'm going to create what I call a semaphore, which is an object which can be locked and released, like when you go on the red and green light. So I'm going to put it as volatile because I'm going to be using it inside an ESR and interrupt, and it can be called also using the second core of the ESP32. So I will say stop semaphore. And we're going to say that this value is null to start. Okay. In my setup function, okay, in my setup function, I'm going to create the semaphore because I'm going to use it afterwards. So the function to create a semaphore is x semaphore create, if I remember correctly. Let me check that because yes, x semaphore create binary. So stop semaphore is equal to x. Okay, I don't have the auto completion for that. Create binary. I need to check if I've got the right library on top of it. Nope, that's why I didn't call it. It's using the free RTOS library, which is really nice, and the test library afterwards. Okay, so now I can have created my semaphore. And what I'm going to do when I'm going to launch my showPixel, I'm going to tell him here, you're going to take the semaphore. So x semaphore, is semaphore take or if? It's always the same Good question. C'est un X sémaphore. X sémaphore. Oh, A. X C. I still don't have the auto-completion on that one. Take. So I'm going to take my stop semaphore. And I'm going to say, you're going to wait a certain number of time. And here, a certain number of time is actually infinity. So as long as I haven't released my semaphore, it's going to stay here, which is good. Okay. But now here in my code here, I need to tell him, by the way, if you finish and you've sent all the different LEDs, I mean like the LED display is more than the number of LEDs that you have, you need to release the semaphore. But here there is a trick. It's because we are inside an interrupt. You cannot, normally the command will be X semaphore give. But because we are inside an interrupt, you can't do that exactly the same way. Just have to copy paste the code that's actually, you know, and you're just gonna up. It just says now we're gonna release the stop semaphore. And here it is. Okay. So here I give back the semaphore from an interrupt, and if I couldn't continue to yield the CPU to the rest of the different functions in the RTS stuff. So now it's still 20. Here in the delay, let's see if my show pixel now is correct and complete. What did I do? Stop semaphore was not declared. Oh, I didn't define the type. Crazy me. It's a semaphore handle. Anyways, we're back working correctly. So now we've done it using like interrupts and double buffering. So what it means actually now you can push a lot of LEDs without having too much of an issue about memory, because you're using only 2 buffers, and the only memory you're going to use is actually the one you will use for your LED array. Okay. So I'm going to push that into the GitHub. So that's the basic of what we do. So what the difference between buffer and buffer, buffer per buffer and the full array. If you have a full array, if you have the memory, you don't have any issues about interrupts and some issues that can happen within the interrupts, especially if you've got Wi-Fi or Bluetooth going at the same time, but you need a lot of memory. On this case, using the different buffer, you have the interrupts that you need to take care of, but there is a way, because what happens sometimes, an interrupts run, but another interrupt which is non-maskable, for instance, the Wi-Fi comes into play and your timing changes, and then you have issue and I would say the display is not correct. But what you can do to do that, first you put all your code in IRAM. That's the first things to do. And second of all, what you do is actually you can increase the size of the buffer that you have, because here we only calculate 1 pixel at a time, but we start with pixel 1. I could have calculated 10 pixels before, and starting when I do my interrupt, calculating my pixel 10s. I send all the pixels and starting from the 10s, 11, etc. So even if at some point of time when I run, I've got an issue because I've got some delay due to Wi-Fi, etc., I'm still 10 pixel. I have a 10 pixel buffer to actually cope with the different change of timing. So it's going to flow without too much of an issue. So that's the second optimization you can do with that code. Okay. So So if you have question about that, just let me know in the comments and the future comments. I need to check if I activated that the replay of the different comments. Okay, but now we still have the issue that if I want to drive 20,000 LEDs, I need to have 60K of memory. And for that, we're just gonna see what we can do here. So here in my function, in my transpose, where am I? Well, in my show pixel here, what I'm doing here, I'm transferring the data with a LED. Okay, this is my function. But let's say that I transport the data with one LED. Okay, but let's say that I've known the LED that I'm gonna translate. So what I'm gonna do is I'm gonna do this. I'm gonna create a new function here. We will just transpose one value somewhere. So transpose one pixel inside a string. Okay, and what I'm gonna do is just take that, but I need to know which pixel I'm gonna send. I'm gonna transpose, and I'm just transposing that pixel. Okay. So now I'm only transposing one pixel. So here, instead of, I'm going to calculate the pixel on the fly. So I'm going to say pixel p equal, let's say I'm going to do one red, one blue, one red, one blue, one green. So how am I going to do that? Offset, multiply, yes. So it's going to be pixel, let to display modulo 3. So that's 2. Okay, let's do that in array. Let's have a table, pixel, flag, 3, all. Pixel, green, red, green, and blue. Okay. So each time I'm gonna call one pixel, flag of 3. And instead of calling transpose with data, I'm gonna call transpose one pixel, and I'm just gonna do p, comma, the pixel, the buffer. Okay. I'm gonna let the first one here in my show pixel. I need to do the same thing here. and here's 0 because I'm going to start with the first one. Here it is. Let's see what will happen if I didn't make too many mistakes in that one. Oh, I've got a 0 to... And if you look at it, now we've got, why do I have two red? I don't know. I need to check why I have two green at the first one. At the end. Oh, yes, because actually it's going, what the first pixel is here. Green, green, blue, red, green, blue, red, green, blue. But it should be, I have two red here. Two blue, two red. I need to know why I've done that. That seems correct. Green. Blue, green, red, when I go up here, I've got other colors, but I don't know why. I've got these. Strange. It's almost correct. Let's do like 128, 128, 128, so maybe you have a better view of what's going on in terms of colors. And 64 is going to be enough. 64, 64. Let to display, yeah, module 3, so it's gonna should be okay. Okay, now you can maybe see better. But why do I have this issue with coloring? Of course, I don't need to do that. 1, 2, 3, and then strange actually. Also have 1 pixel, a phone number, and I send that to him. Let display equal 1. Okay, let's do something like this. I'm gonna increase offset here, and normally it should move automatically. Or my offset define. That is defined on top. So normally it should move. But I don't understand why I have twice some colors sometimes. Okay, it's way too fast. Let's put 300. Okay. So it's moving, but I still don't understand why I have to 2 times the same color. Sometimes. Let me think. I do not touch a palette, I just show a pixel. I don't understand the pattern here. I don't think it's taking too long to do that. Pixel, red, green, blue. Interesting. What did I do when I do transpose one pixel? No, that seems correct. I'm just gonna stop the move. Let's see if I put more LEDs. Push. What happens? I'm gonna mix colors. Remove that. And I can reserve 6 colors. One, two, three. I'm starting with red. So red is here. Red, green, blue, yellow. Match. Ah, it's because I was reading in the wrong direction. That's why. I have to read it like this. I have to read it like this, so that's why. I didn't have any issues. It's because I was not reading in the right direction. It's like green, blue, red. Maybe I can zoom that. Let's see if I can do this. Like that. Up. Lens back. Twice. Up. Yes, we can see better. So we start from, oh, I need to revert it because yes, it's here. My finger is here. So it's green, red, green, blue, yellow, tac, 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 tac. And then I've got blue. I was switching, it was on that direction, but it was on that direction. So the color is correct. I do not have any trouble. So if I go back to modulo 3, this needs to be like the first LED is here. So red, green, blue, 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 red, green, blue. It's because here you've got two of them, but the same, but it's because you have to read the color like this and not like this. That was my mistake. So everything is correct. The code is correct. But as you see here, what happened? Let's put back 6 because it's nicer. We've got more colors. Let's put back more colors. Actually, it's nice like this. Can I go up? Sure. Yes. Okay. Maybe the brightness is a bit too much. Yes, like this, the brightness is better. So, red, green, blue, yellow, blah, 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 blah. So that's the first one, okay? So what is nice in here, if you look at the code in here, actually that we didn't use any, because as we calculate the pixel on the fly, you do not use any memory to store the data. That's what is nice. So here I just created something which is really simple, just a set of colors. For those who join now, I can add my offset again and add first animation. So I didn't need to use any and here you can see the LED moving. But to be clearer, so let's do something which is a bit nicer. Let's have something which, you know, the train. Do the train without, we're going to do the train without any data. So here we say that we know which pixel we're going to have to display. So what I'm going to do is a function that calculates, that returns the value of a pixel based on the position of the pixel, only that. So I'm going to do that. Get palette, I don't care. Flag is here. I'm going to do put that also in IRAM because that's going to be faster. Static void IRAM attr calc pixel value. Oh, and I'm going to base that on position. Okay. Yeah, it's a bit too bright, so what I'm going to do is, yes. So based on the position, I'm going to return the value of the pixel. So because I can use exactly the same function here and here, I don't need to have something which is actually really special. So I'm going to calculate the train. So I have my offset. I'm going to define. Okay, I should not put my define in the middle of here, but in the middle of my code, I do agree. But So I'm going to say, if the position is because I'm going to have an offset which actually displays that. I'm just going to have a lot of modulo to put because I need to be careful. So my position should be greater to the offset. Modulo numlet. And my position should be less than the offset plus the train length. Yeah. Modulo numlet, something like this. I'm going to correct it afterwards. Then I return red, for instance. Otherwise, I return black. It's not void, gives back a pixel. Okay. So here, I'm gonna remove that. I'm gonna call directly this function. Give me that on function of let to display. Okay. And here also. And that's the first value, 0. Let's see what happens if I do that. So here, I'm not using any memory. As earlier, I'm just using the calculation, live calculation set. I guess we're going to have issue around the borders. Pretty sure about that. Oh, look. Here it is. Oh. Oh gosh. Oh, my camera is just a minute back. Come on. Okay, wait. My train is coming up, but let's go faster than that. There's a slow train. Let's go faster. Here it is. So you can see I'm creating a train without using any memory at all, because I'm calculating the value of the pixel at runtime. And that is really nice because here I've got 512 pixels, but I could have 100,000 pixels. It would be exactly the same. I will not use any memory to calculate that. So this is what is really nice. Using that methodology, if you are fast enough to calculate the value of the pixel, you can have hundreds of thousands of LED without no memory. Because I barely use the memory for the buffer, which is actually 18 bytes, 2 times 9, 18 bytes, and that's all I'm doing. And all the rest is done by calculation. So if you're, I would say, clever enough to do the right calculation, normally you should be able to not have any issue. Okay? And that's what actually is important to know. So here you can do 2000 pixels, 5000 pixels without using no memory at all. it will not be an issue anymore. But you need to be clever into the calculation of your, here in that function here, which I call here, calculate pixel value. That's where you need to be a little bit clever in what you do, okay? Let's see if I could actually display the same stuff that I was displaying before. I was displaying, do you remember? I was displaying a little strawberry, okay? Before. So can I redisplay my strawberry within that? So I know that the image of my strawberry is actually inside this here, inside this array of pixel. So if you remember well, we've calculated we had one function which was actually the position function, the map function. So we're going to use exactly the same methodology. If I find my map function is here. Based on the position, I was able to retrieve the 8 where am I on the panel. Okay, so we're going to use that function to know exactly which value I should return. But instead of returning new x and new y, I'm just going to take that here because I don't need new, I just need that. Oh, going too fast. Let's display transpose one pixel, prepare data, I don't care, more, create palette, calculate pixel, okay? Now I know in which position X and Y I am on my array now, okay? I'm just gonna remove. So now to know if I need to bring a value of my strawberry, I need to know if the X and Y is lower than 12 because I know that the size of my strawberry is 12. So if X 12, new X, sorry. And new then I can return the value of the what's inside the peak. So what the value of my array? So normally I've displayed pixel, 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 pixel. Normally I've got press peak. Where is that defined? Oh, yes, it's here. Here, phrase peak is here. Okay, it's defined here. My constant array, because I had too much data in the first one. So now what I'm going to do is I'm going to say there inside of that, I return the value which is stored at that place. So X, new X plus 12 because that's the size of my strawberry, new Y, else black. Return pixel. That I'm gonna comment that part of the code for now because I will come back to it later. And if I didn't make too many mistakes, let's display that. And here my strawberry is back without having to do anything else. Okay, still using because it's stored inside the memory, and I could use it directly like this. I could even do better than that because here is actually I use pixel memory, but remember it was an integer that I could store in the program. Knowing the palette, I could code the palette, the value based on the palette, and then use that to actually display, to retrieve the color. Okay? And here what you could do actually is actually that you can have a set of sprites. You can define the sprites, and you can say, okay, now I want to display all my sprites based on where they are on the panel. And it's going to be also easy to do. And still with that, using no screen memory, you don't need to have the definition of the entire, you don't need to have the display, the memory for your entire display. I'm going to prove it soon, because here I can say that I'm displaying it if, of course, the X are okay. But if I'm defining my panel, I define the panel is, I have two panels here, okay? So I'm just going to say, I'm going to duplicate that. And I'm going to do the following. Pick. I'm going to say if the height modulo 16 is below 12. Normally, it should duplicate the strawberry here, because that's my second panel. They are linked together in the memory. Am I right or am I wrong? Let's see. Oh, totally wrong. Nothing is displayed anymore. Let's see what's going on. Why? Oh, because I made a multiplication. And here I need to tell him not to go above 16. No, that's good. No, that's good here. That's good. I did a multiplication instead of a modulo. Okay, sounds good, but something is wrong, because here I need to return that modulo 16. I need to come back to the right place, because I went too high. I went looking somewhere in memory instead of looking still inside the array of my sprite. Here they are. Good. So only one displayed twice, only using no screen memory. Okay, and that's more or less how is actually the if you know Game Boy, etc. is actually what actually the CPU is doing. It's actually taking piece of memory without having to have the full screen memory, the full VRAM for the screen memory. Can actually display pieces of the background and of the sprites directly on that. So using actually that method, you could actually display sprites and even play game on a full screen, as I said, which could be like thousands and thousands of LED larger, without having too much of an issue, without having no memory at all, except the size for your sprite and maybe the background. But otherwise, you can do whatever you want without having to do anything. Okay. The only constraint that you have, you need to be able to calculate this pixel, the next pixel, before the computer has finished to calculate the previous one. Otherwise, you can get into trouble, because it's like, okay, I need to display the next pixel, but I don't have the time to calculate it, so it's not going to be good. You're going to have a lot of jittering around, but somehow that's the best way to do it. Let's see. Okay. I don't know if you've got questions so far Oh, we are only one person connected. I guess it was maybe too complicated or too technical for that part. So we reduced from using, and let's go back to my numbers. Right, that can. Yeah. So we went to from using, okay, let's say 12, 6K of memory to only plus 9 to display. So can do that normally. To only using 9 bytes of memory to display your screen. And whatever the size is, that will never change because that's not related to the size of the array. That's only related to the number of how fast you can calculate your next pixel before it's been sent out. Okay. Coming into that, let's talk about refresh rate of my screen. Okay. As you remember, it takes 30 milliseconds to 30 microseconds, sorry, to display, to push 1 pixel. So if you want to know the time to actually display your entire LEDs array, you multiply by your number of LEDs, divided by 1 million, 1,000, 10,000. Here it is. And that's the number of seconds. Okay? You've got your FPS. You just do quick manipulation, which is 1 divided by this number. Okay, and here you see that for 512 LEDs, you've got an FPS of 65. Okay, 1024, 32 FPS, blah, 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 and the rest, and so on and so forth. But your FPS is not everything only when you calculate, when you draw pictures. Here, in this methodology, it's actually creating the image is done actually at the same time which is displayed. So it's basically the fastest way to do it, but it can be way complicated to do that, to compute 1 pixel. But normally you've got what? You've got an animation, and then you have the display of the animation. So the total FPS is not the FPS only of the stream, is actually as fast you can calculate plus as fast you can display. So it's actually, if you've got 2 of them, let me write down somewhere, let me get keynotes and I will write down the formula, the formula somewhere. I think I put it somewhere. Not yet. So let's create a new slide. I'm going to display that slide here. Up. And let's display keynote. So why can't I find keynote? Doc Finder Legato. Here it is. Okay. So the formula, if your animation takes T1 in seconds, why can I do that? Okay, let's get rid of that. That's better if I do that myself. If your animation takes T1 seconds, if your display takes T2 seconds, with an S preferably, your total FPS one divided by T1 plus T2. Okay, so you need to take so when you calculate your total FPS, you need to take into account your animation, which could be a lot. So the refresh rate of your screen by itself is not the only thing. You have two ways around it. I don't think I will go through it today. I will go through it in the third place, the third instance. We're going to talk about using the second core and using new array of LED, which is actually more dynamic than the usual one. And the second way of improving that total number is improving your refresh rate. And how to improve your refresh rate is actually, instead of pushing all your LED through one pin, you can push a lot of LEDs to different pins, to several pins. And that's what we're going to start with the next time, because it's midnight. I'm going to shorten my live so I can have more dedicated topics each time. Okay. So the takeout for I would say today is actually that instead of using a huge array, you can use interrupts to calculate each time the next pixel to be displayed. Either you retrieve this pixel from an array of memory, which you usually do, because you get a memory which is actually of the size of your screen of your array. But it can take a lot of memory. But if you're clever enough and if your animation is fit inside of it, you can actually only use very small amount of memory to play with your device, to play with your array, and to display everything that you want to. But it can be quite complicated sometimes. Okay, I will show on my bigger screen next time. I can calculate 48 pixels in less than 30 milliseconds, and so I can display a lot of different funny things without using too much memory. Okay. Let me know in the comments if you appreciate what I've done. I'm going on holidays, so I would say the third instance when I will get really into everything deeper in terms of multi-strip and how I use my new library, which use everything. It's going to be first week of September. In the meantime, do not hesitate to comment, share, and subscribe to my channel. Of course, all the comments are welcome if I can improve in a manner or another one what I've did earlier, what I've did today. I think the camera is better now. I guess there is a better color. I use my phone for that instead of the, I would say, crappy camera that I have. I've ordered a new one, but I did not receive it. I haven't received it yet, so I was, that's too bad for now. So I'm just going to let the stream run a little bit. If you've got questions for now, put them in the chat. If you found this part interesting, also put it in the chat and we can have a small discussion about that. In the meantime, maybe I will try to make this small little, I would say, strawberry move a little bit on the screen, so it can be a bit of animation. Okay, let's go back to my here it is, my code. Okay, now we're back to the code. Please comment in the chat if you want to say something. I will be pleased to know. Okay, so I could actually here in the position so 12 plus offset modulo 16. I should do the part actually. Normally you should see stuff moving. I didn't mess up too much. As usual, it can, yeah, At the X, I wanted to move the Y. I wanted to move the Y. I made a mistake here. It's not modulo, it should be modulo 4. Okay, why am I not retrieving the correct data? Because I need to do that. The position is okay. I have two ends. Let's see if I'm managing to make them move a little bit. Okay, I'm not retrieving the right place because here in the new Y, I need to remove the offset. Okay. Both of them are moving now, which is better. But I can do better than this. Let's really move everything back and forth together. Let's see how I could do that. Okay, how can I display that correctly? So what I'm going to do, it's kind of not part of that, but just going to define the basic of what a sprite is. Let's define a small class, which I will say sprite is. Let's define a small class, which I could real code sprite. Hoopla. So I'm going to move correctly this little arrow around, strawberry around plus x. So the position int position y int width int 8 pixel image. No, we're just not going to sprite. We can define that as structure. But we don't need to have actually that type dave. Yes, I'm going to call that a sprite. Okay. So let's define here. Cell is good. Constant hash. Sprite. Sprites. Define in sprites. True for the moment. And we're going to find one sprite, which is going to be the so sprite. So it's gonna do sprites 0 dot peak equal first peak sprites 0 1 plus 6 equals 0. now we're going to display, I'm going to width and 8. Okay. No, it's 12 and 12 because that's my strawberry. And now we're going to do is actually that we're going to say that the sprite 0 dot position x is equal to 16 times abs of cosinus the 3.14 times offset divided by 150. It should be enough to slow it down. And 32 times cosine of, yes, version y equals that. So now we're going to do something a bit clever than that. When we're going to calculate the display value, calculate pixel value, what I'm going to do with this, so I'm removing that. I'm trying to do something a bit more generic than just that. Let me see. What I need to do is actually to see the position is actually within the range. So if okay, let's see, sprite sp equals sprite 0. Yeah. So where am I? If the new X to display the sprite, I need to be at least at the position of the sprite. And the position where am I needs to be inferior to the position of the sprite plus its width. And I need to be at least within this Y position and at least plus is 8. Yes. If in that case, otherwise I return a black pixel. Pixel. Otherwise, I return sprite picture of, so where am I? where I'm displaying that minus the position plus UI minus the position multiply by the size of the width of my sprite. Let's see if it works. Oh, shoot. Forgot to finalize the definition of my sprite. Ah, c'est image, parce qu'on m'a pas fait ça. Je vais changer ça une picture. Yes, it did not define. Yes. Let's see what I can do with that camera again. Yes, it's closer. Normally should be only one sprite, but moving around. Okay, the compilation is done now. Okay, something is wrong. What is wrong? Okay, let's reboot. I don't see anything. No. I don't see anything. Nothing is displayed. Acheter. Okay, let's start with 0 and 0 to see if it's me who made a mistake in my code. Nothing strange. Let's see if at least I'm returning something. normally it should display only same value, something gray. Okay, that's correct. So something else is wrong. My calculation to define if I'm sprite is I'm in here if the position of the sprite, yes, and if I am inside that plus that, and new y, it's not y, it's new y here. It's not the old position, that's a new position, so I guess that's why it did not display anything. Oh, the camera does not work anymore. Doing stuff, but sorry for that. I had an issue with my camera. I don't know why my phone wanted to play with Snapchat. I guess we're getting there, but it's not right. Funny things, it's way too much in here. So I called for speak, so that's correct. Okay, here. I'm here, that's okay. The new x needs to be less than this position plus this width, and the new y needs to be at least this y position plus this 8. That is strange that I cannot match that. Let me wait. Let me see. Let me think. Let me see. Let me see. Why doesn't display the peak correctly? First, that's not the correct position. This should not be like so. It should be returning 0 each time, but it's not that. let's see, why is it not working? I'm kind of concerned. Let me relaunch this. Maybe it's something strange left it, but I don't understand why it's not working. It should work. Interesting. Interesting. Why is it not working in here? Getting sprite 0. That's correct. Just gonna display. Just gonna. I hope the memory is correct. Otherwise, that means that it didn't get passed through correctly, which could be sometimes issue. So while doing that, maybe the issue I will have some jittering. Okay. 0, 0, 12, 12. So that's okay. Here you see the panic on the CPU because I'm inside the interrupts and it goes way too much time. So that's correct. So I don't understand why. This is not working. Scene fire needs to be lower than that, not superior to that. I'm stupid. And that's why I have this part eliminated and not that one. That should work. Here it is. So now, if I do this, it should move around. I'm going too far, so I'm going to say I'm going to have 8 and 24. I should not put too much out of the. And I'm gonna go faster into that. so the display is smoother. The track of the song, I don't know. Let me check on Spotify. It was Vintage Crown. Let me do that a bit faster. Yes, I've got 150 in dividers here. That's a bit too much, maybe. Why so slow? Yes. Let's try again this times 2 times 2 camera. Brightness seems to be okay. Yes. But what I'm going to do is actually divide the value because it's too bright. So here the right on the pixel, and the pixel actually transpose 1 pixel. And I'm going to do something here. Now we're going to say brightness and transpose 1 pixel. UNTSST. Hopla. Gotcha. Brightness. And here I'm going to do. So if one is 255, that's 1. So multiply by 250. Multiply by brightness divided by 255. I'm going to do that. Now I'm going to call that here. I'm going to call brightness 54. Yeah, it's now implemented the brightness. Yes, you see it was very complicated to implement the brightness. If I put an equal, it's better. Here it is. Okay. Maybe solid was going to be way enough. Okay, so now we have got one sprite, which is done. So I'm going to do is put two sprites. So because I don't have another picture, I'm just going to replicate that. Since that's sprite 1, 1, 1, 1, 1. But what I'm going to do, I'm going to change the position. So reverse it. 16 minus plus 24 and minus. And here I'm going to do a loop through all the sprites for in sprite num equals 0, sprite num 32, sprite num plus plus, up. So what I'm going to do is actually that, because I'm not going to return. Otherwise I return 0. Here, it's not else. If I've done all the sprite, I haven't returned all the sprite. I should be able to have two strawberry going in the opposite direction. Been mistake. And here they are. Two strawberries going in opposite direction without having to use one byte of memory, just full on-time calculation. Okay, it's half past midnight here. I'm gonna stop for today. Still, I hope you enjoy. Let me know in the comments. I'm gonna create the GitHub tomorrow when I'm gonna post my my code. I hope you like the show. There will be, so as I said earlier, third round, first week of September with multiple pins this time. We're going to go back into the big, I would say the big panel, and where I'm going to explain how I do the transposition of the pixel and display, show all the functionality of the library when I've got all that at once. And maybe because I've seen something which is quite interesting actually, which is oh, I need to do something before leaving. The manipulation of subpixel, and you can see that you can do the manipulation of subpixel directly in the driver. Okay, and basically why I do that too, it's because if you have specific needs of what you want to do, it's nice to know how the driver works, so you can actually tweak the driver by yourself to answer a specific need. Something you see that you can see that I have white, I have black stuff here because they do not overlap correctly, because whatever the value of my returned, I always of my whatever the value I return for the sprite, I always return the value of the sprite. But I'm going to do this. Pixel p equal that. And I will return only because by default I'm using which palette? Yeah, I'm using color 111 when I calculate the sprites. Here it is in the setup. Yes. So if I have this color, then I return P, otherwise I do not return anything. That means normally they should overlap correctly this time. But maybe I need to implement, yes, of course, because he doesn't know how to make this kind of comparison. I need to add that in the library. I need to add the comparison. Let me check into that again. Okay, here is my structure. Here I've got pixel attributes. I'm going to add these two in line. So I'm going to overwrite the equal operator and the difference operator. So normally now, except that I turn it the other way. Should have put difference. Yes, I return only if the pixel is not that. Now I'm going to have a subtraction. Now they should overlap correctly. I hope so. Yes. Now you see, yes, it's purely overlapping correctly now. Yes, maybe I will make yeah, that's C++ stuff. So overriding the operator equal. So two pixels are equal if all of these numbers are equal, and the difference if at least one of them is actually different, or that's just the opposite of that one. Okay, here it is. Okay, maybe what I can do is that just let's finalize that once. If I can find the if I find the cherish. This is the cherish. Let's calculate that. And which so let's calculate series and let's put that in here. And the size of the cherish is 14 by 14. So we have two different actual. object moving around. It looks better. Yes. And what I'm gonna do is actually move that a little bit. Then, yes, put just 10 should be enough. Funny how the red of the cherish looks redder than the red of the strawberry. The same, but because of the blue inside the strawberry, it looks a bit different. Here they are. So you see here two sprites mixing each other. Of course, the strawberry, the cherish comes before. That's why it goes. That's what we do. The one coming before is actually the one on top, because that's the one returning values. That's an easy now. Okay, so now you can display sprites. So now you know how to display sprites, value of sprites, and now you can see how you can do a game without using any bytes of any memories, except the one for your pictures, without too much caring about how big is your array. Could be like 10,000 pics on the Arduino Uno. Okay, so this is the end this time. So see you in see you in 2 weeks for the next big step on that. I hope you still like what I've showing to you and how to use LEDs and the driver. Okay, please comment, subscribe, and support me. I've got a nice link for the donation if you want to. Bye bye.